in here. Now, I know we've thrown out a lot of paper at you, okay? For the most part, from an operations point of view, the only reason we did it is it gives an outline of the feed system, okay? Basically what we're going to be training on is on the Acroson chemical feeders, the fluoride, the phosphate, and the Permanganate. Thank you. Okay. Now the three handouts I gave you guys is one shows a basic overview of the feeder, and the other one is an overview of the panel, which from an operational point of view, all you care about is on the left-hand side. Okay. Even though it's 6 feeders, 2 per each chemical, they're very, very similar in operation. Basically, the feeder is the same design. It's it's a model 105, and what you have is you have your feed auger, and what you have inside of it is what's called an intromitter. Okay, and on the feeders, especially the one with the dust collector, we can open that up and you guys could actually look inside very easily, and you'll see what that is. What happens is the intromitter turns about 16 times slower than the main feed auger, and the idea is to prevent bridging from happening. Okay. Now on a couple of the feeders there is a vibrator that is on a timer. It comes on for a short amount of time and then is off for like 5 or so minutes. Okay. Mechanically, what you have is you have a gearbox back here, okay, where there's open gears that turns the intromitter. Okay. This needs to be greased about every 3 months of 24-hour operation. In the manual, of course, from Keystone number 29, or millennium-based type of grease. It's not an oil bath. Okay? And then what we have is a gear reducer back here, which is lube for life, as they say. This is actually how fast the auger is actually turning. Okay? Now, what I also have here is sheets, because one of the questions that I probably brought up is what rates, where do you set these up at? Okay? Now, these are going to be run automatically from the skater. But what we have here on these sheets, when you take a look at these, you'll see we have the auger capacity and the flow rate, or the rotometers. Okay? So I don't know how you're going to set it up from the skater. That's okay. But the one thing that you guys mentioned the other day was you guys are going to take samples so you know exactly what comes out of the feeder. The one thing that we did talk about the other day, and you guys, the rest of you will see it, is there's a little housing there. We were talking about putting the bolts underneath it. I was thinking about that. That may not be a bad. That might be a bad idea because then the bolt, if it comes loose, gets into the tank. Okay, we don't want that to happen. So we'll go out there and we can discuss that a little bit, and just leaving it the way it is. Okay. The other thing that I made a copy of for the maintenance guys is in case you have to clean out, not clean, change out the dust bags in the dust collectors. There's 4 dust collectors out there that are all the same. Okay. Maintenance? I'm sorry. I was going to say, then you don't need these. You need these. Okay. Now what these are for the maintenance guys is it's got the same things as the operation, but the actual drawings of the panel is included here, so you don't have to go to the O&M manuals. Okay, and the drawings are in the O&M manuals also. Okay. Okay. Now the main difference is between the 2 main systems out there. You have the fluoride and the phosphate, and you have the permanganate. The permanganate has just a wetting cone. So you're going to have a swirl of water, and you have the adductor, so it's going to go on out. The other 4 feeders have got a dissolving tank. Okay? So that's where the main difference are between the 2 of them. Basically, from an operational point of view, the way the system is designed, you put it all in auto, and the skater system starts it. Okay? But what we're also going to do when we go out there is just quickly go through about how to run it in manual, just in case you ever had to do that. Okay? Basically, I just wanted to get everybody in here, hand you all the paperwork, because everything is more important out there to show you that out there. Okay, so let's go out by the permanganate. It's amazing how it just Okay, what we have, okay, just what we were showing you, we have the feeder, okay, you have the gearbox, you have this gearbox, there's a tach so we can get down to the low speeds, like 5% or so, and you have the DC motor, and on the other side you have your wedding cone, okay. Now, the way the panels are designed is you're going to put everything in auto, the skater sees that it's in auto, and then it's going to run it, okay. This contraption here is a hoist. What will happen, hopefully, is you'll get a little drum that will fit in there, and what it will do is this piece here, okay, these pieces here will all go onto the drum. This will clamp onto the top of the drum, okay, and what will happen, okay, is on this, if you look, there's a little switch on the here that says power. And you can actually tilt this all the way around. And then this lever down here just relieves the hydraulic pressure just to lower it. Okay, if you want to lift it, okay. But the way it's designed is you would put the drum in here, you would clamp it onto here, okay, and when you close it, you would actually tighten it into the drum, okay, with the ratchet. So you would actually put it in here, and then as you tighten it, let's go a little looser. That would tighten it up, okay, and then with the other piece, of course once you have the drum in here, it works a lot better. Then you would lift it up, spin it around, these pieces would all be in here, you would lower it in, and then you would open up the valve here, okay. So when would you do this? Well, you will do it when you get a hot below level, okay. Now, when you do get a hot below level, okay, it isn't like you're going to run out of product in the next 5 minutes. Okay, these are all low rate feeders. So you're probably talking about a good half an hour before you really get down that low that you got to really worry about that. Okay? But what it means is that when you get the low level, is you can't change out the valve at that point. Okay? Now the way the system would work, let's go over and look at the panel here. By the way, they're not labeled, but this panel is panel number 1. And goes to the feeder over there, and then this feeder goes over to the far one over there. Basically, normally what you would do is put everything in auto, okay, and then the system would run, okay, from the skater. One of the things that you guys brought up was you guys want to take samples of the product. Well, how would you do that? Well, you're not going to want to run it in auto and have water, so what you would do, basically, is you would put this in hand, and then you would run off the thumb wheel over here. 100% means you would run the motor at 100% motor speed, 99.9. So when we run this, you can actually see the feeder running now. Okay, and we don't want to do that for too long. So what you would do is, you get your bucket underneath there, start running it, and then time it out, and as best you can to get your sample. Okay? Generally, this is going to be in auto. When it's in auto, that means it's getting the signal from the skater system to control that. Now, if for some reason, if you're not going to control it from the skater, what would you do? This is what you would do. Okay? You would run it in hand. So what would you want to do? Okay? Well, the first thing is you want to start getting some water in there. And do I have all the valves open? I think I do. So the first thing you want to do is turn on the inductor. So now we got water coming through there. Then we turn on our cone. Okay? And if you look inside, you should get a nice inductor, and then this is your flow based on these sheets. Okay, depending on what speed you're running at, what solution strength you're going to be running at. Okay, I don't know what you're going to do chemical-wise, but this is the one you're going to adjust based on whatever your flow rates are going to be. Okay. Now, from a maintenance point of view, the only thing that we have inside the panel here is we have a couple of timers, and this is the 060 motor controller. One of the other panels I have the cage off to make things a little easier, so we'll go through that. Okay, but it's just relay logic, so when you look at the drawing, you'll be able to figure out if there's, like if you get a feeder along or a mixer, not in this mixer, but if you get a feeder along, it will shut you down immediately. A hot below level though will not. A feeder along would be, if this light starts blinking, that means we got an overload. Like a good chunk got in there that couldn't be broken up and got jammed up or something like that.
But that's coming off the motor or something?
That's coming off the motor, right? Not off the auger. Okay.
That hopper level, what was that? This white thing?
That's the hopper level, right? So what you got is a little vindicator that turns around. So we always want the chamber full of product. Okay, so we get good feed coming out. So when you're talking about here, so you still with that low rate, even at 100%, you're still talking about at least an hour or maybe 2 hours if you're at 100% speed. Okay. But those are your flow adjustments. Basically, what will happen is when you shut things off, there is a slight timer. So when you do shut off the inductor, it does go through like a 10-second timer to flush through the lines. Okay? If you guys need to increase that, that's just a little digit-set timer. In other words, you find out that it takes longer to go through all the piping, you can increase that flush. Okay? Right now I think it's set to about 10 seconds, which is probably not going to be good enough, just looking at the way it's piped right now. Okay. From what I can understand, looking at the piping and that, this system is basically designed to run one feeder. Okay, although I did run both feeders and didn't have any problems with the water. Okay, but from what I understand, it is designed to run one feeder and then you switch over to the other feeder. Okay. By the way, there is spare augers. Okay, different size augers. I know on the line system they're different size. Okay. This is, but I don't know who's responsible for this, but obviously the feeder needs to be empty. To change out the auger, pretty straightforward. You just unbolt the cylinder, and the auger is threaded on. It's a left-handed thread though. Okay, so as it rotates, it self-tightens. Okay? Now the only thing you have to be worried about that from a maintenance point of view is in a few years, if you ever have to change out the DC motor, just double check the rotation quickly. Okay? From the back hub, it always goes counterclockwise. Okay? But if you change out the auger, you just put some loop braid never sees here, and it just threads right onto the shaft. Okay? There is no shear pins or anything like that in there that can break. Okay, any questions about the lifter? This is the only system that's got the lift, by the way. The other ones, you gotta use your own muscle. Okay, it's pretty simple. It's got lift, tilt. The only one that you don't know is this one for the drop, the lower. Okay, and they need to be charged up. Okay. So if you've been using them, you just plug them in. Okay? Any questions or anything? Okay. Let's go next door. Like a pump to pull it out. Fluoride. This is fluoride. Fluoride. What did I say? Phosphate. Oh, okay. And that is a big difference because the fluoride you do have to be careful about. But I don't think I need to explain that to you yet. And you do have a mixer that's on here. And if you notice, if you look on the panel, the mixer is not part of the auto or hand circuitry. on and off. The idea behind that is if you shut this down, okay, you're still going to have the solution in here. So you can leave the mixer running all the time. Okay, the only time you don't want to leave the mixer running is when you drain out the tank. Okay, because then there's nothing there to support the shaft. Okay. The other thing you have on here that's very different is you have a dust collector. Okay, so what you got is a couple of things here. Is you want to throw that switch there? That's basically what you do. Now, if I open up that, okay, go ahead and shut it off. Now you go ahead. Okay, so what you want to do is open that up, then turn on your dust collector, and then put the bag in. You'll see there's grates inside, so you cut open the bag and you put the bag in as far as you can, and then it should pull it out. Now, what you should do every, after you get done, is you take this handle and you pull it in the bag. Okay, that works. You can actually see it here. Okay, you drop the other product that comes in here. Okay, the maintenance guy, in that little thing I gave you, this entire thing, you actually move this, and the bags don't come out individually. It's actually all on this piece of plastic. So
come out that top.
Yeah, it comes out through the top. It actually comes, I think, comes to the top, and then when you put the new one in, it shows you coming in underneath. Okay, but you don't do the individual bags. Like on the silo ones, they're the individual bags. This one is all together. Okay. And by the way, all 4 dust collectors are the same. Okay, so you can get one. How long will the bag last? Again, that depends on the product and how often you're filling it. Okay. Same thing, you have a low level here. Okay, you have a gearbox, tack, and again you have your auger. Okay, and the auger will go into the tank here as the mixer is running. Okay, one of the questions that were brought up before is you have these rotometers. What was the question you were going to ask?
I was asking you what, you said something, I didn't understand what you're saying.
Okay, excuse me. You have 2 rotometers here. The big one is for your inductor. Okay, as you can see, there's no individual control here. Okay, it should be turned on full because we want as much pressure to go through here. But where you change your solution strength is based on this. This is your flow going into the tank.
We won't be doing that.
How are you guys going to be doing it?
We change the strength of the solution by the amount of product.
So you're going to set the water in one thing and that's it?
Right.
Okay.
We'll set it at 1 thing for us.
What one thing?
Whatever goes, whatever flows to it.
Whatever flows in there right now, 5 to 7 gallons a minute. Is that all right?
Depends. I had these fully on. Okay. Because I had it fully on because I wanted to make sure the inductor could take it away. Okay. Now the other thing you do have that's very different than the other 2 is you have a scale here. There is a meter that's up there. Okay. The meter is set up for 0 to 500 pounds. Okay. That means most of the product you can put in here is about 500 pounds, which should not be a problem. Here's why. Okay. Fluoride is approximately about 75-80 pounds a cubic foot. This is a 4 cubic foot hopper. So that means that would be 80, 160, 320. Okay, and you could probably put another 80, probably another 40 pounds in here. So 500 pounds would be right about here anyway, for the most part, about 450. Okay, but that's, if you go up there, the scales have already been teared off, and they will be reading about 1 or 2 pounds right now. Okay, in fact, if you take a bag here, and take this 2 pounds. Okay. So it's all calibrated and everything like that.
So you should never bring that product from that grade, is that right?
No.
No.
We shouldn't be doing it.
No, that's a good question. Well, here's the reason why. You come up in here, the dust collection is gonna have problems. But more importantly, you could end up having bridging because now my instrument that's down there is not gonna be able to do anything up here. So this could actually, you could actually come up here and say, wow, it says there's 100 pounds in there. You open it up and say, why, it should say 500. Well, it's stuck here. Okay, so that's a good point. Yes, you never want to go above the grade. That is a good point.
Last
On your last bed. Yeah, if you come up over the grade a little bit, that's fine. But once you get up to the grade, that's when you're done. Okay. Yeah, it's on the scale.
The whole thing, you know, that scale.
Yeah, the whole thing is on the scale.
Oh, yes.
Right. And it's already tanned off all the equipment.
How much you lost.
Right. Well, that's up to the scale. I don't know what they have on the program. They want to make sure they had a signal insurance. That's what they definitely have for the affiliated devices. So this is the stuff you want to turn on the dust collector? Switch. Yeah, we just wanted the office covered. It's up there.
I think I'm sucking it out of the bag.
You got a lifter? Now we have four. We're going to do it, not here yet, but we're going to do it. Carl, are you gonna have you lift one fella up? No, they all go stack. Stack. Yeah.
That's to keep the dust down. Here, I'm going to hear that floor that's a little hot.
This is always running.
Right. So your water meter over there, if you look behind there, you have your flow meter. That's where you're at, right?
I guess any problem with splashback.
No, not on this one, no. It's all flow, flow, and and if you notice on that panel, the hot below level went up because we went above the flow. should be, when I get done with the class tomorrow, train all the tanks.
What are we gonna be using?
In 2 weeks.
2 weeks, so we should drain the tanks then. Okay, because I don't want to keep the mixer running for 2 weeks if we don't like it. Okay, no, that's why I was just wondering, when we're done with the class tomorrow, I'll drain it. So we'll, you know, I guess there's no big deal.
Well, let me ask you something. We think we're running valid concerns about the water. Probably nothing to you guys. Is this something we can pipe back into this meter instead of pulling it over?
Well, that's the best way to go, to drain. Once you point it back into the tank, then you have a chance of not running as well.
Shoot straight down.
I've seen where customers have run into back into the water lines and that problem. What you guys here is the best. And what you got to remember is what you have in here is probably 99.9%.
That was my concern, the pH of the solution.
Well, that's why you heard this, you should get very little. When I saw here, it was very little dust in anyway. I mean, it's not like wine. Okay, so we go to the last room. It is a lot smaller. Okay. Do you guys want to run a product in this also?
Yeah, I'd like to.
Okay. You guys want to, let's, always like 25 down, you know, they're all, that's a tough one. So that'll probably. When you change out the organ, if you put the same size organ, then you wouldn't be changing out the cylinder. Let's say if the organ got damaged or something got in there, damaged some of the organs, you know, we gotta change it, pull it apart, you change out the same organ, you don't need to do it. But if you put a larger or smaller organ in there, you're gonna get a cylinder. The cylinder is already gonna have one in it, so you're not gonna have to worry
Isn't that
about
gonna
it.
be pretty tough to get off right here? And slide all the way out there?
Well, once you undo that, you can actually pull it up with the auger. Yeah, it's not easy, but yeah, you can maneuver it.
Make something, can this handle be rotated this way?
Not that I know of.
Hit that roll pin.
Yes, that's what it looks
Couldn't you do it 180 and push it?
like. I don't know, I've never tried that.
It'd just be easy if you had it.
Put it down here.
Like this.
Do it 180 and push it.
I have to check with the door.
You probably would hit that. It would do it. You might have.
Yeah, I don't think you could get here. same type of waveforms that the larger design. That's your inlet, right. This is your inlet. This is coming off your inductor. This is coming off the inductor. Right, that's your inductor. No, it's not a bad, it's not a small valve. For the other one, there's nothing else up to show. Rob was already looking at doing it. I saw that the other day, and I said, I've done enough training, I know there's a person that they're all going to complain about. You guys are working wrong.
Any idea what the maximum back pressure is on these?
I have to check with the salesman, depending on the inductor and the pressure.
I mean, we don't have, we typically have a gauge or something monitoring that back pressure. We don't have anything. Is that something we need to add?
The only time you really need to worry about that is right now you're going into an open system, so you're not going to have any back pressure.
Oh, yeah, right now, no.
But that's also why, if you notice, the pressure that they're supplying is so high. If it takes a high pressure, you usually find it goes in some type of back pressure. What I can do is find out from, depends on the induction you're going down the pressure. Okay, so I'll walk down the pressure you're running at, or the back of the sales.
I'd like to know what the maximum back pressure is. We're over the side.
Okay, maintenance guys. Show you the 06. This is your DC motor title. This is your analog board, and this is your main drive board. These are your SCRs.
This is analog board.
Yeah. Okay. Now, this 060 is the same on all 6 chemical feeders and on all the feeders in the silos. Okay, so bottom line is, if you know that you're only going to be using one system at a time, if something fails, you can take the parts out of one, put it in here, and then order something from it. Usually these last for a few years, easily. I know customers have had for 10 years and never touched it. Okay. But that's what you have is the and you have the entire heat sink. So what you would do is pull out these wires, pull out these connectors. Why do they do this?
Yeah, they always do that.
Cut this off, and and replace the whole thing.
These are where it gets power off of it.
Yeah. This is your motor wires, this is your AC. This motor starter is for the mixer. This vibrator, this is for the vibrator, which I had off before, so we didn't. And this is your timer, your off and on timer for the vibrator.
So the vibrator is just on or off, is there an intensity setting for it?
There's weights inside for intensity. Right now they're set to medium. There's 1, 2, and 3, so they're always set at 2. That's your timer. So if you find that you're getting a little bit more bridging or something like that, then you want to shorten the time in between. Okay, but there is a switch here. It's an overload. If for some reason you didn't need the vibrator, that's when you would shut it off. I don't
But this
think
has
you
to be
would.
on for it to run.
Yes,
What'd you say these were?
that's your motor starter for your mixer. Okay, and when you guys are running off the SCADA, all these switches have to be in auto position, and this switch. So you can't say, I'm going to put them all in order, but I still want to have control over this from here. That's not going to work. The SCADA won't be able to start this.
Hey, y'all listen to this.
And everything else has to be on, make sure it's on.
Right. All your switches here have to be in the auto position for the SCADA system to run this system. That's true of this system, the Fluoride system, and the Permanganate system. They're all the same. The key is, it's not these switches, it's also this switch. So you can't sit here and say, I don't want the SCADA to control my 4 to 20, okay? I want to do it from here. Well, you can't put it to auto. Put this, when you put this to hand, then you use the thumb wheel here, just like we were here. Okay, when you're using the auto, then you get the signal from the SCADA. But basically, all the switches have to be in auto for the SCADA to control this. And of course, this switch has to be in the on position. This is actually a 20 amp circuit breaker. So if there's something that really gets in there, jams up really fast, that's an overload protection. Otherwise, what will also happen is if the motor or something's in there, or you leave product in it for a long time and it binds up, this light will start blinking. When this light is blinking, that means the unit is drawing more amperage, it's going in the current limit. You will get an alarm back on the SCADA saying feeder alarm. Okay, but if you come out here and see it blinking, most commonly it's something stuck inside the feeder. Okay, could be something mechanically wrong with the feeder, the motor, the gearbox, or something like that. Okay. Just for, I don't know how you guys are, but I know many other plants with something that open, it's amazing what falls inside these feeders.
Amazing what comes inside the bag.
That's the scary part. I mean, we do a lot of testing and they send us fresh product, we dump it out, and it's amazing what you find in there. You find scraps of wood or something, it's like, didn't they scrap? Did they
We'll
sweep
probably
this
put
up?
a little fine screen
Yeah.
up there, it's what we normally do.
Well, that's where you got to be a little careful about a screen, because then the product may not get through the screen depending on the mesh.
It wouldn't be that fine, I mean, just something
Okay.
a little bit more than that.
Can you break this down for us? This, like I'm sitting here looking at this inductor
Okay,
motive water valve. I'm assuming that's the cylinder.
motive, okay, the adductor is the main one that's pulling the water out of the tank.
So that,
Okay.
is that
The
energizing the solenoid? That's energizing.
By that, all this is doing is, so you have two solenoids over there. One for the adductor, one that puts water into the tank.
So that's all that means.
That's all that means. So when the light comes on, it's telling you that the solenoid should be energized. The light does not mean that the solenoid is sending back a signal saying it is energized. It's saying it should be energized, your water should be on, okay? A lot of people get those type of signals mixed up.
And it's not saying that it's working correctly either.
No, it just means that it should be turned on, right? If the valve is, there's nothing here to measure flow of water either. So if the valve is turned off, this doesn't have water pressure or anything like that. The silos do have water pressure, for instance, but these don't. So there's no way to know if somebody comes in here and shuts off these valves, you don't get any water, and yet you would still be pumping in a lot of product into it.
So I have a question on that. You know, right now, this PRV that's over here that controls that water supply, which is also this water supply, has not been set yet. If that gets adjusted, is that going to adjust this?
It's a possibility.
Now, what's the design operating pressure of this system?
Each one is a little different, but like, the permanganate thing is 114, the fluoride's like 130, and this one is like 115, 120. On the drawings, the outline drawings I gave you, on one of the notes, it's in bold, it tells you the minimum operating water pressure.
Really?
Yes. And when what we're talking about there is not for the incoming water, it's for the adductor. That pressure we need for the adductor to push it through.
Or 1,200-foot pipe?
The information you gave us, all that's in the O&M manuals?
All those are in the O&M manuals too. Everything I gave you today is right out of the O&M manuals.
So you said 130 and 114?
Something like that from what I
So
saw.
I'd assume the 130 is the brick.
You'd have to look at the drawings.
Right.
You'd have to, I don't know what they are off the top of my head.
Driving ahead through the solid 114 is straight over.
Where's the disconnect to lock that thing out?
Well, I say it's in the book.
There's switches, circuit breaker switches.
the end, down by the end there.
You fire that up again.
Miss, but
If you feel power here, there's no power there.
that's my problem.
Power here is, you still have power here, going through the switch, you'll have power down. Yeah, there's circuit breakers. When I was taking off the cage, I was cursing out the engineer. Give me a little more.
That's a troubleshooting line. Well, this right here.
Well, that definitely has to be functional. Everything was siphoned right back into the tank.
I would say you need a gauge here, a gauge here, on this side of this. If you had a gauge here and a gauge here, you would know when that was. But when right now, you only know when it's working or when you cut it off and it slams back and it ain't functional. It'll get hit.
Can we override it again, override SCADA from out here? You know, like the other, say we just have two.
He said SCADA cannot override manual.
But
Can
manual
manual override SCADA?
Yes, you can run everything manually,
from out here.
yes.
So if SCADA is on,
If SCADA, if you don't want to run it from the SCADA, you can run everything in hand out here.
we have a drive system currently in our stuff, and it's one of the newer systems. And if the SCADA has it locked, you have to stop it from SCADA before you can start it manually.
No, not this.
Not this one. So
No,
there's
no, it's not that sophisticated. It's not that, what that sounds like what's happening is the system is talking to the SCADA, actually physically talking. This is using very simple analog signals. So if you, in the middle of the night, say something's messed up with the SCADA and I have to keep running, I'm just going to put everything in hand and just let it go. And when you put the feet of the hand, that means that thumb drive is going to be 0 to 100%, depending on what you have it set at.
So what happens if we have a power outage? What happens then? You lose power?
You lose power.
It doesn't restart? Or does it?
Power goes out.
If the power goes out and power comes back on, if the SCADA closes the contact to it, it will restart. If the contact coming from the SCADA is open, then it won't restart. See, if it's an automatic, the SCADA is telling it to start. Now, when power comes back, since it's all relay logic, if that contact is closed, then the unit's going to try to run. If everything is in hand and you lose power, when you get power back up, everything's going to start running again.
Y'all understand that?
Power glitch will come back on, going SCADA still telling.
Basically what he's saying.
Right, that is correct. In order
That SCADA PLC panel over here, right?
Right.
If that contactor in there, any of those relays, if they're closed, that means this will restart.
Right. So the question that you're
Depending on
asking,
that, it's dependent on that.
correct. So the question you want to ask SCADA is, if we have a power outage, when we power back up, are you going to tell the Aquason to start back up again, or do we have to go through?
No, that's okay. I can ask Terptron what they do.
Okay. Well, that's what I'm saying. That's what you have to ask.
They close.
Right.
That's okay. Figure that out.
But since that's all relay logic, it should, if you're in hand, it'll start right up immediately. If it's in auto, it depends on what the SCADA is telling it to do.
So on a manual day, when they come out here, they will turn every switch on manual. Not just the top switch, all the switches. All the switches will say things.
Right, I would believe the way you guys want to operate it is everything should be in auto.
If we require once a month, we go to manual day, operate by the computer as much as we can.
Oh, so what, the operator would come out here and put everything in hand? Yep. Really? What's the reason for that? Just to...
If you lose the computer system, you know how to operate the computer.
Okay, that's a pretty good idea. That's a pretty good operating system.
Not just computer nerds.
You are, not just. All right.
I will be here all day tomorrow, so if you guys have any questions, I'll either be here or I'll be working on the silos, checking out a few last things in the afternoon, so if you have any questions, come and find me.